In semiconductor electronics, from the present day syllabus, the amplifier is one of the expected questions for 5 marks. To understand the working of transistor as an amplifier, first let's go to some of the basic concepts of transistor. We know that there are two types of transistors. One is NPN, the other one is PNP. When NPN transistor, every transistor consists of three elements: emitter, base and collector. Now in this is emitter and this is base, and then this is collector. It is already known to us that base is lightly doped. In fact, this property of lightly doping this base only gives us the amplification. Transistor was designed primarily to amplify the signals. Now we prefer NPN transistor over PNP as the mobility of the majority carriers in NPN transistor, that is electrons, and the mobility is more than the mobility of the majority carriers in PNP transistor, which are holes. So as the mobility of electrons is much more than the mobility of holes, so this is the reason why do we consider NPN transistor. Now transistor can be operated in three different modes: common emitter, common base and then common collector. Now in the syllabus of CBSE, common emitter is only there. Why common emitter is preferred over common base? The gains, the current gain, voltage gain and power gain are much more when compared to the common base configuration. Now how to connect the transistor? So this is the symbol of transistor. Now if you take NPN transistor, this is NPN. Now you should remember that always the base emitter should always be in forward bias. So I must connect the P to positive and then N to negative. So this is called forward bias. Now collector should always be connected in reverse bias. That means N type collector is here, therefore it should be connected to positive, and then so one must remember the base emitter should always be in forward bias and collector should always be in reverse bias. If you remember these facts, then we can now describe the working of transistor easily. The one more factor is that the emitter is only supplying the current with for base as well as the collector. So the equation IE is always equal to IB plus IC. Now as base is lightly doped, most of the electrons will go to the collector region. So this helps us to amplify the signal. Now let us see the circuit diagram of transistor as an amplifier. So as I told you, this is common emitter mode. See, common emitter means the emitter the emitter must be in the input and it should be in the output. So here this is base, this is emitter and this is collector. We are discussing for NPN transistor. Therefore, this is N, this is P, and this is N again. The conventional current direction is always from positive to negative. Therefore, the arrow mark is to be fixed from P to N. Now, this emitter current IE at this junction will be splitted into IB and IC. So this IC and this is IB. Now this is IE. We have to supply the batteries in both input and output. So here this battery is VBB and this battery is VCC. The resistance that is connected in this is named as RB and this resistance is named as RL. Now to amplify, we have to connect one signal to the input. Now let's connect that signal here. This VI, which is an alternating signal, we keep a capacitor here which blocks DC, which allows only AC. Now if you go through the simplest schematic diagram of an amplifier, this is input signal and for this the corresponding output signal. If you look at this, for this positive cycle I have taken in the output negative cycle, and then for negative I have taken in the positive. So this is called phase reversal. Shortly we will discuss how phase reversal occur in NPN common emitter transistor. Now if you take the graph between output voltage and input voltage, here we observe three different regions. One is cutoff region, the second one is this is cutoff region, this is active region, and this is saturation region. Transformers, transistors as an amplifier should be working with this active region only. And to select a point which is known as operating point, that operating point should always be somewhere middle in the active region. Okay, now let us write some of the basic equations that are related to the circuit. Suppose if the input signal is not supplied, that means Vi is simply 0. At that case we can write according to the Kirchhoff law, VBB must be equal to VBE, which is the voltage between base and emitter, plus the potential drop across the RB. This is one important equation. Now if you write the equation, remember this when V in is 0. Now the corresponding equation for the output, I can write it as VCE which is equal to VCC minus IC and RL. So this is another important equation. Now the third equation, it is very simple, which relates IC, IB and IE. So IE is always equal to IC plus IB. Remember, this IB is very small when compared to IC. When small change in IB will bring large change in IC. So in fact this is the secret behind the amplification factor. Now when here you can see some capacitors, as I have already told that these capacitors are blocking DC and allowing the AC. So here we are amplifying the AC signal and the corresponding output we will be getting in opposite phase, which is also known as phase reversal. Now if when V in is not equal to 0, that is when V in is introduced, the signal that is to be amplified is introduced in the input, then what happens? The first equation will be VBB, in addition to that V in, which is AC component, is equal to now VBE plus IB RB, and by introducing this V in, the AC component, there will be some change in base current. So this, due to this base current, change in base current, some voltage drop will take place. Here this R in is the AC component, the resistance corresponding to AC component. So now if you observe this carefully, we from the first equation we can cancel it. Now if you replace this value by simply R, then the equation will be V in will be equal to delta IB times R. Now this is nothing but delta VBB, the change in input voltage. So this is the value. Now if you take the output voltage, that is if you take the second equation and if you observe the change, VCE must be equal to delta VCC minus delta IC RL. Now we know we are not introducing any signal in the output this battery. the signal is introduced only in the input. Therefore, I can say delta VCC, there is no change. Therefore, it is 0. Now, that implies delta VCE must be equal to delta IC times of RL, but with negative. So this negative sign indicates this phase reversal. Of course, we will explain the phase reversal in a different manner also, but simply this negative sign can indicate the phase reversal. Now, if you want to find the voltage gain, then what happens? The voltage gain AV is equal to this delta change in output voltage, that is minus delta ICRL and delta IB times of R. Now you can neglect this IB, you can neglect this IB RB as it is very less. Simply we can write IB times of RN. Now this RL is greater than this R, therefore this RL by R, which is known as resistance gain, and delta IC by IB we have already defined as if it is beta AC. So beta AC as delta IC by delta IB, we can write AV, that is voltage gain, is equal to beta AC times resistance gain. Now if you want to write the power gain, we know that power is nothing but the product of voltage and the current. So here the power gain comes with beta square AC, because once again we have to take this factor delta IC by delta IB. So beta square AC and resistance gain. We know that resistance gain is always greater than 1. So in that way we can get large gains in this one. Then power gain, one should not misunderstand that power gain means this transistor works as power generating device. No, it's not a power generating device. Then who will increase the amplitude of it? These batteries, the battery that is connected in the output will increase the amplitude of the input signal. Now, and after some time these batteries will be consumed. That is the important factor. So there is no free lunch. So these batteries will be consumed after some time, and these batteries energy is only used to increase the amplitude of the signals. Now we can explain the phase reversal in a different way. So we know that this is phase reversal. Now if we take this one, we can explain like this. Suppose if positive cycle comes here, then this becomes more forward, because more positive, more potential difference, more forward, more IE, more IC, then larger value is to be subtracted from this delta VCE. That means the value of output is decreased, therefore the negative cycle is accepted. Now if negative cycle comes here, it reduces the it becomes less forward, because it becomes less positive, less forward, less IE, less IC, and we are subtracting very small quantity from VCC, therefore this VCE is positive signal is accepted. So in that way the transistor, this NPN transistor under CE mode will always have a phase reversal, or the input signal is always out of phase with the output signal. So when it is positive, this becomes negative, but the power gain and amplitude, the voltage gain, current gain will always be very much higher. So CB, in CB if you observe this, you will always get the gains with alpha factor, where it is very less when compared to beta. So beta is delta IC by delta IB, whereas alpha is delta IC by delta IE. Therefore delta IE will be more. If the denominator is more, then automatically the factor will be reduced. So alpha is always lesser than beta. So there are one first thing is why NPN transistor is preferred, because the mobility of an electron is more than the mobility of holes. That's why we prefer NPN. Why CE mode? Because in the common emitter mode the gains are connected with beta. Then what happens when if it is connected in CB mode? In CB mode the input signal will be, or the output signal will be in phase with the input signal, or you can say the positive corresponding positive will be there in the output, for negative corresponding negative will be there in the output. So to describe transistor as an amplifier, one must write, first we have to mention this circuit diagram. You have to remember this P type should be connected to positive, because emitter base junction should always be forward biased. Forward bias means P to positive and N to negative. So therefore you can remember this circuit diagram very easily, P and this positive, and collector should be in reverse bias, therefore N type collector is here, therefore it should be connected to the opposite terminal of the battery, that is positive. So and emitter comes in between because we are discussing common emitter mode, and it should be grounded. So as emitter is existing in the input and output, we say that it is common emitter mode. Next you have to write three equations. VBB, that is for input, VBE plus IBRB, and then for output VCC is equal to VCE, the voltage between the collector and emitter, and that must be equal to the net voltage minus the potential drop across this RL. So this is second equation to be remembered. And the third equation, we know that IE is always equal to IB plus IC. By applying the junction law at this junction, you can get this with the help of Kirchhoff law. Now after introducing Vin, we have to, what is the change in input we have to find out, then what is the change in output. So change in input means this Vn, because this is VBB is already there, we are adding one more